Hey everyone, this is Maths Guy Channel here, and today we're going to be going through logarithm and exponential laws. Um, I kind of assumed that you guys already know what these are, but this is going to be kind of a quick refresher. So a logarithm, for example, if you have 10 raised to the second power, that's 100. And so you can, if you want to work out the power of that, you would say that log 10 of 100 is 2. So when that equation asks us log 10 of 100, it's kind of asking what number do I raise, what must I raise 10 to in order to get 100. Um, yeah, that's a relationship. So like if the second example, e raised to x is y, then log e of y is x, that sort of thing. So in the first example, there 10 is the base number, and 2 is the exponent index or power or whatever term you use for it. Yeah. So what is this number? E. It's around 2.7182. It's an irrational number. That means it's a number that cannot be expressed as two ratios, such as square root of 2. You can't express it as a fraction because it keeps the decimals don't terminate. And also when you see the form log ln of x, that is a natural log of x. So ln of x is the same as log e of x. So underneath that is this sort of table list of rules, the log rules. So this is from the Jacaranda Mathematical Methods book, 6th edition, I believe, for 2019 study design, if I sourced that correctly. So yeah, I was using those images whenever it's just way too much writing or like for visual effect. So the first one says log a of m plus log a of n is log a mn. So when you have logs of the same base and you add them together, the numbers inside multiply. And the opposite is true. So if you subtract it, so log a of m minus log a of n equals log a m divided by n. So addition of logs in the same base is multiplication. Subtraction is division. If you have log a of m raised to a power, the power goes outside as a coefficient. So log a of m raised to n becomes n log a of m. Log a of 1 equals 0. That makes sense because a raised pretty much every number raised to power 0 is 1 except 0. That's a different story altogether. And log a to a is 1 because what power must a be raised to get a? Then that's 1 already. So that sort of makes sense. Log a of 0 is undefined because you can't really raise any power, a number to any power, to get 0. And log a of x is defined so long as x is greater than 0 and a is a real number, a positive real number except 1. There are other ways of going about this, but for our purposes, these rules will be that rule 7 will be applicable. And a raised to log a of m is just m. Okay, so let's go through an example here. So it's a simplified log 4 of 64 plus log 4 of 16 minus log 4 of 256. So first of all, you realize that I didn't recognize that 64 is 4 raised to 3, 16 is 4 raised to 2, and 256 is 4 raised to 4. So you can use law 3, so you can raise the power out, take it as a coefficient, and use law 5 to realize that log a of a, or log 4 of 4 is 1, so 3 times 1 plus 2 times 1 minus 4 times 1, 3 plus 2 minus 4, and that gets you 1, and that's your answer. If you have another example here, like log 2x all squared equals 3 minus 2 log 2x, so you solve a as log 2 of x, and you solve it as a quadratic function. You get these two numbers, a is 1 or negative 3, and you substitute it back, you get a is 2, or so x is 2, or x is 1 over 8. Yeah, this is the example for that. This is the change of base rule. So you have if you have a equation y equals log a of m, a y equals m, a raised to y is m. What you can do is take log b of both sides, log b a y, a raised to y equals log b of m, and y equals log b of m over log b of a. And so therefore you can have log a to m equals log b of m divided by log b of a. That's sort of the proof of how you can change the base of a logarithm. Okay, that's the logarithms. And we're going to be going through integral equations, which shouldn't be as long. So if you have 3 of x equals 3 of 4, you can match, since the bases are the same, you can say x equals 4. And same with x cubed equals 27. X cubed equals 3 cubed, so x equals 3. So if you have the last example, 2x equals 2, it's not so obvious how you would begin solving for x. So we'll quick note that a of x equals b, and solutions for b exist if b is greater than 0. So these are the index laws that really should be assumed knowledge of this, right? So a times a to the m times a to the n, powers add, and when you divide them, the powers subtract. Powers powers raised to powers, they multiply. Gives a, b, or m. It becomes a to the m, b to the m. Same with a fraction, a divided by b or m, all raised to the m. So it's a to the m divided by b to the m. Any number raised to 0, any to 1, any number except 0 raised to 0 is 1. A divided by minus power becomes 1 over, it's a over minus m equals 1 over a to the m, where a isn't 0. A 1 over m is the m root of a, and a n over m is the m root of a raised to the n. And that, we'll also remember that a to the x is greater than 0 for all x. These are, like I said, the index laws. These sort of assume knowledge. Hopefully. So you have an example here. 7 raised to x minus 3 minus 3. 7 raised to the power of x minus 3. All of that minus 3 equals 0. You take, you separate, you take log x, move 3 to the other side, take the log 7 of both sides. And x minus 3 equals log 7 of 3. Because you take the power of x minus 3 out, and log 7 is 1. So you have x minus 3 equals log 7 of 3. And move 3 to the other side, and you get x equals 3 plus log 7 of 3. Yeah, that'll be all.